The Nautilus project aims at developing, evaluating, and validating a highly efficient power generation system for long-haul passenger ships. Conventional ship propulsion systems have relied on heavy fuel oil for a long time, utilizing large diesel engines for power generation. The combustion process emits pollutants that contribute to global warming. It is leading to air and water pollution and is negatively impacting human health. The growing shipping sector transports the majority of global commerce and contributes already to around 3% of global greenhouse gas emissions. Triggered by this fact, the International Maritime Organization set a goal in its initial 2018 strategy to have ocean vessel emissions by 2050. Cruise ships represent a small percentage of the global fleet, but they are an important segment of the leisure travel industry. When operating in proximity to coastal and urban areas, they are often bound to strict local regulations. These regulations comprise also the harbors, where cruise ships are docked with continuous engine operation. The transition to sustainable solutions is vital for the cruising industry. The Nautilus project aims to develop, evaluate, and validate a highly efficient, dynamic, and sustainable marine power system, combining a solid oxide fuel cell powered by LNG with a battery system. Nautilus addresses the complexity of power requirements of cruise ships with high-temperature solid oxide fuel cells. Fuel cells in combination with batteries can supply the dynamic power demand of a ship while providing usable heat for its services. This system offers substantial emission reductions compared to conventional propulsion systems. A modular design approach reduces the risk of power supply failure with enhanced dynamics, allowing efficient operation. Additionally, the technology is adaptable to various fuels dependent on the level of development of the port infrastructure. Let's take a look at the key components of the system, starting with fuel cells. Fuel cells are electrochemical devices that convert fuel to produce electricity with minimal environmental impact, a promising technology for marine applications. Nautilus was able to verify that SOFC systems can withstand the motions and accelerations present on seagoing ships with static and dynamic inclination tests.
So a typical example for a cruise ship is that the power is divided into three categories: the hotel load, the propulsion load, and the load for instrumentation. Today, we are seeing ourselves first catering for the hotel load, which is really, as the name says, is taking the need of the people staying in the hotel or the cruise ship. We might go scale up to a second level where the instrumentation load, which is the need of the power, as well as the hotel load will be covered by our technology, finally going to the large step where the propulsion load will be covered. So take an example of typical ship which will host about 10,000 customers at a time, will require close to 30 to 40 megawatt of a power plant inside, out of which almost 40% is required for the hotel load and rest goes for the propulsion and instrumentation.
In order to power an entire passenger cruise ship, scaling the SOFC systems up to a multi-megawatt SOFC power plant is crucial. Within Nautilus, the scaling is addressed by a modular 110 kilowatt SOFC unit being designed and integrated. The arrangement of the SOFC units within the ship's room layout is prepared and reflected against marine safety codes. Batteries are supporting the SOFC units in the most dynamic scenarios of the cruise ship's power requirement. In harbor mode or whenever the power demand on the ship is lower than the SOFC installed power, the batteries are charged to ensure that sufficient energy can be provided by the battery for an upcoming acceleration and maneuvering. Batteries also supply additional energy when leaving the harbor and maneuvering at sea. A significant portion of power is required by hotel amenities. The high dynamic capability of batteries covers rapid changes in the ship's power requirements. To manage these scenarios, the Energy Management Unit is employed for efficient power distribution according to the power demand and system safety. In the demonstrator phase, a custom-sized container houses the energy management and battery management units, battery rack system, power electronics units, and main control unit to ensure safe and stable operation. The hybrid genset modularized demonstrator consisting of the battery container, the SOFC system, and other auxiliary components is currently assessed and validated for performance under various load scenarios. The demonstrator is now installed at DLR Stuttgart, and efficiency testing and detailed emission measurement are ongoing to validate the reduction of CO2 emissions and non-CO2 emissions. The latter are referred to as air pollution. Air pollution has severe health impacts. An analysis conducted in 2 areas affected by shipping-related air pollution revealed that 0.4% and 1.7% of deaths are linked to particulate pollution exposure from shipping. Preliminary emission analysis of the genset developed in Nautilus project operated with natural gas shows potential for 99% reduction versus major diesel engine exhaust gas and particle components. Further detailed measurements will be conducted using natural gas on the genset demonstrator. SOFCs fueled by synthetic fuels can offer not only even greater CO2 reductions, but also air pollution reduction, a promising path towards net zero emission maritime transport. Nautilus is a research project coordinated by the DLR German Aerospace Center, Institute of Engineering Thermodynamics. For further information, please visit our website and social media channels.